Welcome back. This is lesson 18.2. In the last lesson we learned what a compiler is. In this lesson we'll look at the stages of the compilation process. There are 4 stages: lexical analysis, syntax analysis, code generation and optimization. Here's a reminder: a compiler takes a file written in any high-level language and produces a second file of machine code called an executable file. This is actually a 4-stage process. So let's go through the 4 stages one by one. This slide shows all 4 stages with a quick overview, and then we'll look in slightly more detail at each stage. At lexical analysis, the compiler checks that every word or symbol used in the program is the correct one. For instance, it'll spot your spelling mistakes at this point. At the syntax analysis stage, it will check that the symbols are correctly used, in other words, that the words are in the right order. At code generation, the commands are turned into machine code, and at the final stage of optimization, optimum means best, the best. So at optimization, it's checked to make sure that it's the best version you can get. So let's go through those 4 stages in just a little bit more detail. At lexical analysis, as you know, comments are ignored by the computer, so the comments are just discarded. So any comment line is just discarded by the computer at this stage. It's not going to be turned into machine code. Empty lines and extra spaces that you've added can be removed at that point. The variable names and other identifiers, like the names of methods and functions and so on, are stored in a table, so the computer remembers all the different identifiers that you're going to use in that program. And then the computer will look for special words like keywords, Python keywords, the names of inbuilt functions, the key operators and so on. And what I've described that here is they're tokenized. That is, the computer kind of stores them as a token that reflects what it is that the keyword or the operator is supposed to do. Here are some examples of valid tokens: the keywords, the identifiers such as variable names, the operators, the connectors such as commas or colons. Comments are just tokened out, and literals, by literals we mean things like the actual strings and floating point numbers and so on that are being processed by the program. So here's a little activity. I've written the different token types with a bit of an explanation for what they mean. So if you are keeping revision notes, you could copy this into your revision notes, and in any case complete that final column to give an example from Python of each type of token. So hit that pause button, fill in that answer, and I'll give you my answers in a second or two. So there we are. Keywords like if, identifiers, obviously you make those up, but stuff like total. The operators, I think they'll all look familiar to you. There's some literals and some connectors and comments. In Python, they're marked by a hash, or you usually mark it as a triple string, triple quote mark string. So those are at the lexical analysis stage. The different lexical items are tokenized. At the syntax analysis stage, the compiler checks that all those tokens are correctly used. For example, that the body of a loop is indented. That would be a Python thing, or that the words are just organized correctly. Then, when everything is neat and correct, the compiler creates machine code to match each of the instructions of your program. Typically, although you'd think it only needs to go through once, it normally goes through several times to get that completely right. And then at the very last stage, the code is optimized. That means made as good as it can be. The computer only uses an algorithm to do this, so it doesn't use any common sense, but it's got some things that it checks for. Unnecessary repetition, variables that are never used, and they'll be trimmed out. Stuff that's not really going anywhere, loops with nothing inside them. And that makes the code short and quick to run. So to recap, the process of turning a program written in a compiled language, and I've used Python as an example because you can get compiled Python, but any compiled language, the compiler carries out 4 stages. First of all, it analyzes the lexical symbols used by the programmer, then it checks the syntax, then it makes the machine code, and finally it has a last check through, which we call optimization. If you're my student, of course there's a worksheet on this, and you can find that on the Moodle. Okay, so in the next lesson we'll look a little bit more deeply at how we can use code libraries and so on when we create computer programs. So bye for now.